Hello everyone, welcome to my your programming club. Today we will be solving another daily Leetcode problem, and the problem's name is custom sort string. So you are given two strings, one is order and other one is s. So all the characters that are present in the first string, that is order, are unique, and those were sorted in a custom order previously. Okay, so there is a certain order in which they were sorted. I am talking about the first string that is there, the order string, this string. Okay, and what you have to do is permute the characters of s. Okay, so there will be characters present in s, and we have to permute them according to the uh, orders, so that they match exact. They match the order that order was sorted in. Okay, more specifically, if there is a character in s, let's say x, that occurs before characters y. So let's say there are two characters x and y in s, and those characters are also there in the order string. So the relative ordering of x and y characters in s should be same as it was in order. Okay, what I mean by this is, let's take this as our example. Okay, and let me take it to the board. Yeah, now it's fine. uh, See that this a, b and c are also present in order. Okay, and they are having a certain ordering here, but I mean, c is appearing at the first position, and then b is appearing at the second position, and a is appearing at the third position. But here in s, a is appearing at the these positions are relative. Okay, so c is appearing before b and a both, and b is appearing before a, and a is appearing at the last. But here it is not the same case. A is appearing before b and c. Okay, and b is appearing before c. Okay, here the case is not same. So what you have to do is, for all the characters in s that are already there in order, their relative ordering should be same. So this should have been c, b and a, and then whatever character is not present in order, we are not really concerned with this position that will be in our resulting string. Okay, so s will be converted into a resultant string, or let's say a result. So d can be placed either here, uh, anywhere you may prefer. So here, here, anywhere you may like, it can be placed. Okay, so it is also mentioned that if a character uh, okay, and this is the permutation part, or let's say the ordering that I have just talked about, and return any permutation of s that satisfies this particular property. Okay, so and you may see the explanation part also. For example 1, it is mentioned that d does not appear in the order, so it can be at any position in the return string. Okay, so this is also acceptable, this is also acceptable, and this is also acceptable. Okay, so all are valid outputs other than this. So as I told you, these can be the possible positions of d. So we are not really concerned about the character which is not present in order. Okay, so that is what the problem statement asks you to do. It is a very straightforward thing that they are asking you to do, and we will be doing just according to the rules, okay, or as per the problem statement. And before moving to our approach, let's see what are the relative constraints, what are the constraints here. So you see that the order length will be at max 26, and it is mentioned that both in order and s the lower English letters will be there, and the length of the string s that will be given to you will be of order 200. Okay, and all the characters of the order are unique. Okay, so these are the constraints. So as per the constraints, as you can see them, that they are quite manageable here, you know. So constraints should not be our major concern here. Anyways, we will try to implement the most optimal approach that can be there. So what we will be doing is uh, we will be having a frequency map. Okay, character frequency map to be specific. And if you want to be more specific, then S character frequency map. It means that for the characters present in S, we are building a frequency map. So what I mean by this is, let's say this is the character and this is frequency. So A was present only once. Okay, let's say S would have been A, B, C, C, C. Okay, and then D. So what would have been the result then? You see that C will be occurring first, so all the occurrences of C will occur first. Okay, and then B was occurring, so all the occurrences of B, since B is occurring only once, and then A, all the occurrences of A. Okay, so this is how the relative ordering works. And then D can be placed anywhere you may like, so here, 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 or here. Okay, so let's say I place it here. So this would have been the resultant string. Okay, if S would have been this. Okay, so anyways, A is occurring only once, and if you take this as our example, let's take this only. So A is occurring twice here, and then B is occurring once here, and then C is occurring thrice, and our D is occurring only once. Okay, so this is the character frequency map of S if S is this. Okay, we are not considering as this particular string as of now, and order remains the same. Okay, so what we will do, we will traverse our order from left to right. Okay, C, B, A, we will pick each character one by one. So let's say you are at this character, you will see whether this character is there in a frequency map or not. Okay, if it's there, okay, C is there, we came to know that C is there. So we will see what is the frequency of C. Its frequency, let's say, is frequency. We are storing its frequency in a variable frequency. Okay, so we will be making our result string along the way when we are traversing this order from left to right. Okay, initially it will be set to empty. Now you have seen that C is there and its frequency is 3, so you will add C 3 times. Okay, now coming to this B, how many times B is there? First of all, you will check whether B was at all there in S. So yeah, indeed that is the case, and it is occurring only once, so you will be adding it only once. Then for A, you will see whether A is present in S or not. Okay, A is present in S, and while you are using the frequency of every element, so we just used the frequency of C and B, so you will set their frequency to 0. Okay, I'll tell you why we are setting their frequency to 0 further down the line. Then talking about A, we will be adding A 2 times and setting its frequency to 0. Okay, so we have done traversing this whole order string. Now what we will do, we will traverse the string S again from left to right. Now we will traverse S from left to right. Okay, why we are doing so? We are checking are there any elements that are left out in the frequency map, and if it is the case, then we are free to place those elements anywhere we may prefer. Okay, so if uh, character frequency map is still having a occurrence of a particular character, let's say current character. Okay, then what you will do, you will just add that character to the result. Okay, and decrease its frequency by 1. What I mean by this is, let's say we are traversing A, B, C, D from left to right. First you will be at A, you will see that A's frequency is 0, so it will not be added. Then B's frequency is also 0, so it will not be added. Then C's frequency happens to be 0 also, so it will not be added to result. Then D, you will see that D's frequency is not equal to 0, so you will add D only once. Okay, let's say there are other D's also, so you will add for now D only once to the result, and then you will move one place ahead. Okay, and then you will also decrease the frequency, so this frequency 1 will be reduced to 0. So since we are decreasing the frequency by 1 while we are traversing S from left to right, so this is what we are doing to make sure that there is nothing left out from S. Okay, so that is how we will be solving this particular problem. This will be the approach. Let's see the implementation. Okay, and if we talk about what will be the time and space complexities here, then you can see that let's say that order length is let me change the color here, it's L M N. Okay, and S length is, let's say, M. So how many times what will be the time complexity? Time complexity wise, it will be order of N plus M. Since we are doing a linear traversal here, in order also left to right and S also left to right, so this will be the time complexity. And if you ask me what will be the space complexity there, so it will be number of unique characters in S. Okay, number of unique characters in S. So this will be the space complexity, because this much space will be used up by this frequency S character frequency map. Okay, rest there is no space that we are using, extra space, so these will be the complexities. Okay, so now moving back to the implementation part that I was to show you. So this is the implementation. Today I have done the implementation in C++. Okay, so this is the character frequency map that you will be building for the characters in S. Okay, so once you have built the character frequency map for the characters in S, then you will start building your result string. Okay, and you will, as we discussed in the approach, first of all traverse every character in order one by one. Okay, and this is what we are doing indeed. And then what we will check, whether this character is present in s or not. Okay, if that is the case, then we will add that character to the resultant string. How many number of times? The number of times in which it was occurring in s. Okay, so frequency number of times we will add that character, and along the way we will also reduce its frequency in s character frequency map to 0, so that we should not be picking it up again when we are traversing s from left to right, so we should not be adding that character again. Okay, so that's why we are setting the frequency 0 here. So for the next step, we will be picking out those characters which are left out in s, okay, whose frequency is not 0 till now. Okay, so if there is a character in s whose frequency is not 0 as of now, you will add that character to the result string and decrease its frequency by 1, indicating that we have used its one occurrence. Okay, and then you will simply return your result. So this is how you will be solving this whole problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.